A blessed morning to everyone. I am Irma Torillo, teaching at Santa Barbara National Comprehensive High School. I will going to discuss about descriptive statistics, and I will focus on the measures of central tendency. Descriptive statistics is a term given to the analysis of data that helps describe, show, or summarize data in a meaningful way, which allows simpler interpretation of data. For example, if we have the results of the tests of 50 students in math class, we may be interested in the overall performance of those students. Therefore, it is very important to learn the measures of central tendency. Here are the objectives that you're going to learn about the measures of central tendency. First, differentiate the measures of central tendency, the mean, median, and the mode. Calculate the measures of central tendency of ungroup and group data. Identify the appropriate measures of central tendency from a given situation. Measures of central tendency is a single value that is used to identify the center of the data. The first type of the measure of central tendency is the mean. The mean is the same thing as the average or arithmetic average, which is the most common measure of the center. To compute for the mean of the ungrouped data, you have to sum up all the data divided by the number of data. In symbol, we have the mean is equal to x sub 1 plus x sub 2 plus x sub 3 and so on until plus x sub n divided by n, which is the same as sum of x sub I, where I is the first element of the data and n until n, where n is the last element of the data divided by n. The mean is easily affected by extreme values or outliers. Outliers means that values are very low or very high among values found in the data set. Okay, so we have here two diagrams, okay, to represent, okay, what we call the data set. Okay, so we have 1, 3, 5, 7, 9 for the first diagram, and to compute the mean, okay, of this 5 numbers or scores, all you have to do is to get the sum divided by, okay, the number, okay, the number of scores. So we have divided by 5, so the mean here is equal to 5. And for the second diagram, still we have, okay, 5 elements in our data set, and those are 1, 3, 5, 7, and 14. And after computing the mean, okay, we have the value, or the mean value is equal to 6. So the mean value of the first diagram is much, okay, higher than the value or the mean of the first diagram, because of our outlier, which is 14, because the last data we have here in the first diagram is much higher than the last data we have in the first diagram. The mean, the characteristic of the mean. There may not be an actual observation in the data set. It means that not all the time that the mean is found in the data set, and it can be applied in at least interval level. And the major advantages of the mean is easy to compute, uses every item in computation. And the major disadvantage is it is as easily affected by extreme values, okay, So it is already explained in the first slide. And the mean for the group data. To compute, we have the formula. The mean is equal to the sum of f(x) sub m divided by n. So we have here the steps in computing the mean of group data. First, determine the midpoint or class mark of the given class interval. Multiply the midpoint of the frequency f(x) sub m. Repeat this step for each group of data. Find the sum of the values obtained in step 2 to obtain the sum of f(x) sub m. Divide the total in step 3 by the sum of these frequencies. Okay, we have here the illustrative example. We have the problem. Below is a frequency distribution of the number of 58 students spent on Facebook. Given what we call the class interval, the frequency, all you have to do is to look for the midpoint. In the midpoint, okay, for the first group, we have from 5 to 9, so the midpoint there of this class interval is 7. So to find f of x sub m, all you have to do is to multiply the frequency and x sub m. Okay, so example, 1 times 7 equals 7. Okay, the rest of the group, you're going to do the same until we find what we call the sum of f(x) sub m, which is 1,816, and the total frequency, which is also equal to n, is equal to 58. So by substituting these values in the given formula, so the mean time of 58 students spent in Facebook is 31 and 31 minutes. Okay, let us now proceed to the median. The median divides the observation into two equal parts. It is very important that we are going to arrange first the element found in the data set before we're going to look for the median. Okay? If the number of observation, which is represented by n, is odd, the median is the middle number. Okay? So, if n is even, the median is the average of the two middle numbers. Let us consider these two diagrams here. In the first diagram, okay, the number of observation or the number of data we have is 5, and 5 is odd. So the middle number here is 5. So therefore, the median is 5. Okay, next, in the second diagram, we have the number of observations we have for data, for elements, we have 6, and 6 is even. So to get the median, all you have to do is to identify the two middle numbers, and these two middle numbers are 5 and 7. So what is the average of 5 and 7? So that is equal to 12. So 12 divided by 2, because we're going to get the average, that is equal to 6. So therefore, our median is equal to 6. And to compute for the median of the ungrouped data, we have the formula. Okay? If n is odd, the median is equal to x sub n plus 1 divided by 2. And if n is even, the median is equal to x sub n divided by 2 plus x sub n plus 2 divided by 2 all over 2. And to compute for the median of the group data, okay, so we have the formula. The median is equal to L, the true lower class limit of the median class, plus n divided by 2 minus less than cumulative frequency or CF all over F sub m times I. Okay, so n stands for the total number of observations or frequencies, while less than cumulative frequency is the less than of the class preceding, okay, the median class, or less than CF is less than cumulative frequency of the class preceding the median class. And F sub m is the frequency of the median class, and I is the class size.